Hello students and friends, welcome to my YouTube channels. Today we are going to discuss the steps of solving the force convection problems. Before this video, I discussed the process and one problems also I solved. So force, already convections we have two types, natural convection and force convection. So this I am discussing force convection. How will I know the force convection? If the velocity given in this question, if velocity will be given, this is called the force convection problem. So force convection problem, these steps I wrote. These steps, all the formula will be there in the data book. But what are the steps is there? First, we'll see the velocity should be given. So if velocity given, some more questions also I wrote here. Flows over a flat plate of velocity 5 meter per second. That means velocity given means that is called force convection problem. Then force convection problem is there. Then will first step will be will find the film temperature. Film temperature, what is TW plus T infinity by 2. So TW is plate surface temperature, T infinity is a fluid temperature. So after finding the film temperature, we'll find the status of the fluid. How we'll find the status of the fluid? Fluid is either laminar or turbulent. So laminar formula is there, Reynolds number. Reynolds number is equal to UL by nu, velocity, length and kinematic viscosity. So this, if we'll substitute all the value, if it's getting less than 5 into 10 power 5. So here Reynolds number what is UL by nu. So U velocity, L length, nu is kinetic viscosity. If this value coming 5 into 10 power 5 less than laminar flow, if this value will come more than 5 into 10 power 5 turbulent flow. Once we know the either laminar or turbulent, now this I wrote the steps for the laminar flow only. So for flat plate laminar flow, what is the steps? So problems they given flat plate laminar flow, flat plate. So laminar flow came because Reynolds number less than 5.10 power 5. Now look here steps. If laminar flow, local Nusselt number, this value will be there in the data book. What is 0.332 Reynolds number power 5, Prandtl number power 0.333. So we'll substitute this Reynolds number and Prandtl number. The Prandtl number value and all will take from the data book. And we'll substitute, we'll get this Reynolds local Nusselt number. Again local Nusselt number is equal to HXL by K. So from here we'll find the local heat transfer coefficient, we'll find HX, local heat transfer coefficient. Once you'll find the local heat transfer coefficient, then average heat transfer coefficient nothing but for the flat plate H into H is equal to 2 into HX, 2 times of the local heat transfer coefficient. Then we'll substitute heat flow rate, HATW minus T infinity, surface temperature, film temperature, area, local, this is average heat transfer coefficient, and area will find out, breath into distance, breath into length will be the area. So we'll substitute. If they will, I ask hydrodynamic boundary layer thickness, this is the formula. Thermal boundary layer thickness, this is the formula. Local heat transfer coefficient, this is the formula. And average heat transfer coefficient, this is the formula. This will be there in the data book. So now look these questions, how we'll solve. This always will be there in the data book. You have to understand that these steps. So each and every video, these steps I am discussing. So if problem they will give now, how we'll solve. So what is there? Air at 25 degrees Celsius. So film temperature is 25 degrees Celsius. Then flows over flat plate, speed is velocity is given 5 meter per second. And heated, surface temperature will be 135 degrees Celsius. And plate is 3 meter long and 1.5 meter wide. 1.5 meter wide is there. Okay, so 1.5 meter wide is there. 1.5 meter wide is there. Okay, correct. So now they are asking, find the HX. HX means local heat transfer coefficient they are asking. Find the HX, that is called local heat transfer coefficient, and heat transfer from the first 0.5 meter. Generally sometimes they will ask, find the entire length, but they are asking here only 0.5 meter of the plate. So what is this one? Heat transfer. Heat transfer they are asking. Two things they are asking. So what is the heat transfer formula? HATW minus T infinity. What is the unknown here? H unknown. Area you know, this temperatures you know. What is the H? average heat transfer coefficient. Then for this local heat transfer coefficient I need. Local heat transfer coefficient how will find? From the Nusselt number. The Nusselt number how will find? This is the relation. So first steps what will write here? Reynolds number you will check. Reynolds number equal to U. U how much? 5 into length how much? Because length we have to check 0.5. 0.5 by kinetic viscosity. So this kinetic viscosity and all will take from the, okay, first fluid film temperature will see now. Film temperature how much? 135 plus 25 by 2. So this is 160. So 80 degrees Celsius. What is 80 degrees Celsius? Film temperature. From that film temperature, what is the value that we will see from the data book? So density will be there 1 kg per meter cube at 80 degrees Celsius. Then kinematic viscosity will be there 21.09 into 10 power minus 6 meter square second. These are the units. Then Prandtl number will be 0.692. Then kinetic, this is thermal conductivity will be 0.03047. This unit is watt meter Kelvin. This value will take from the data book at 80 degrees Celsius. Once we will see this value from data book, now we will write the status of the fluid. What is status of the fluid? Is nothing but UL by nu. U how much is there? 5 meter. L how much will take? 0.3 because they are asking first 0.5 of this plate. So 0.5. And kinematic viscosity 21.09 into 10 power minus 6. This value will come. If we will calculate this value, this is 0.5 given, no? 0.5. This is 0.5 meter. First 0.5 meter. So this value is coming how much? 1.18 into 10 power 5. So which is less than 5 into 10 power 5. So flow is laminar. So flow is laminar now. So flow is laminar. What is condition given? Flat plate laminar flow. So this is the steps. Already we wrote now. So Nusselt number, see here. Directly I am writing mu x. Nusselt number at x. That means at x na 0.5. So this formula I am not writing. Directly I will substitute the value. Directly we will substitute the value. What is 0.332? What is Reynolds number? 1.18 into 10 power 5. Power is 0.5. Power is 0.5 into Prandtl number. This one 0.692. Then 0.333. So this Nusselt number, if you will calculate, it is coming how much? Already we calculated. Nusselt number calculations will be there 100.9. Now you know the Nusselt number is equal to how much? HXL by K. So Nusselt number will be this. HX I need. L is equal to 0.3. So one more steps I will write 0.5, not 0.3. Why I am writing 0.3? So 0.5 only they are asking. And K thermal conductivity 0.03047. So you will get the HX, that is called local heat transfer coefficient. This also they are asking. What they are asking? Local heat transfer coefficient. So local heat transfer coefficient you will get 6.14. 6.14 local heat transfer coefficient. Then what is average heat transfer coefficient? Average heat transfer coefficient H is equal to 2 into HX. So 2 into 6.14, it will come 12.28. 12.28 watt meter square Kelvin, because local heat transfer coefficient is this. Now what is their heat transfer? Q they are asking. So what is Q is equal to here? Q is equal to formula is there. What is HA? So here HA, TW, surface temperature, film temperature, H na 12.28 into area. Area how much they given with 1.5 into 0.5. 1.5 into 0.5. Then what is the temperature? 135 minus 25. This value will come, that Q will come. How much? 1013.9 watts. So this they are asking in this question. So look here, question this much, very small question. This is the steps we have to find out, and this is all the value will be there in the data book. This all the value will be the data book. If the same question they will ask, find the hydrodynamic boundary layer thickness. If the same question they will ask, hydrodynamic boundary layer thickness. So delta Hx equal to 5x, 5 into 0.3 into this Reynolds number 1.185 power minus 5, answer will come. If they will ask thermal boundary layer thickness, delta Hx the same value in Prandtl number power minus 0.333 thermal boundary layer over. Local friction coefficient they will ask na 0.664 Reynolds number 118 into 10 power 5 power minus 0.5. You will get the local friction coefficient. If there is average friction coefficient 1.328 Reynolds number the same value power minus 0.5, will get this answer. So this is the possible, like this question, either they are asking local heat transfer coefficient, heat transfer, average heat transfer coefficient, hydrodynamic boundary layer, thermal boundary layer. This is all the formula for the flat plate laminar flow. This is the formula. If we will see this value is coming greater than 5 into 10 power 5 turbulent flow, this value will change, this formula will change, this formula will change. So that we will see the later video. So this video for what? Solving the force convection problems in flat plate when this fluid status is laminar flow. So these are the steps. So this very simple. If you practice, you can solve these questions very simple way. Okay. Okay, students. Thank you. Watch this video. Share this video to your friends and subscribe the channels. Okay. Thank you.